Efficiency of a cycle. Source QH. Working substance QC sin Tc. Wn is equal to work done by working substance upon heat supplied. W upon QH is equal to QH minus QC upon QH is equal to 1 minus QC upon QH. For carnot cycle, QC upon QH is equal to Tc upon Th. N is equal to 1 minus QC upon QH is equal to 1 minus Tc upon Th. Refrigerator, source Th, working substance to source Th by QH, sink Tc to working substance by QC. Coefficient of performance to working substance by W. B is equal to QC upon W is equal to QC upon QH minus QC is equal to TC upon TH minus TC. Carnot engine. It is a hypothetical engine with maximum possible efficiency. Process 1 to 2, 3 to 4 are isothermal process. Process 2 to 3, 4 to 1 are adiabatic. Second law. First law is quantitative analysis, while second law is quantitative analysis of thermodynamics process. Second law tells us in what conditions best can be converted into useful work. ds is equal to change in entropy d theta best exchange. ds is equal to dq upon t. Work done is least for a monoatomic gas. Adiabatic process is shown expansions. Isobaric, isothermal, diatomic, monoatomic, adiabatic, PV. At a particular pressure and volume, magnitude of slope of PV curve is greater for adiabatic Yp upon V than isothermal P upon V. Air quickly leaking out of a balloon becomes cooler as the leaking air undergoes adiabatic expansions. First law of thermodynamics does not forbid flow of the heat from lower temperature to higher temperature. First law of thermodynamics allows may process which actually don't happen.